So, one thing that Nate and his cohorts found frustrating last year was the sheer number of instances in which we use the letter K. So we have K's now that we're going to use here. We're going to use Ka, Kb, and Kw. Okay? So, at 25 degrees Celsius, what is Kw? Well, what would Ka be? Let's maybe hold this question off for a minute while we address some other things. Okay? When we talk about Ka, what are we talking about? Okay, it has to do with K indicates an equilibrium constant, right? Okay? So, what we're looking at is concentration of acid as opposed to concentration of... Right. So, what we're looking at, if we kind of go back to here, we're looking at concentration of this just compared to concentration of that. Okay? And since this is a liquid and we don't really care much about the concentration of that, do we? Okay? So, Ka is just going to be concentration for water, for this specific case. Okay? So, one thing that will always be true Kw is going to be Ka times Kb. In other words, the dissociation constant for water will be the dissociation constant of an acid times the dissociation constant of a base. Okay? Hold on to that thought for a second, we'll get back to it. So, at 25 degrees Celsius, we have to find out what Kw is going to be. Well, to find that, we need to learn about Ka and Kb. At 25 degrees Celsius, and we should say here, in pure water, what is Ka?
So is it the concentration of the acid compared to the water?
It's the concentration of acid compared to water, but since water is a liquid, we don't include it in the expression. So it's just the concentration of water, or acid, excuse me. And what is that? What is that number? 1.0 times 10 to the minus 7 moles per liter. All right? Kb is equal to concentration of hydroxide ion, which in the case of pure water is by definition the same as the concentration of the hydrogen ion, which makes it 1.0 times 10 to the minus 7 molar as well. All right? So Kw is going to equal what? (1.0) times 10 to the minus, what is it? Minus 14th. Just add the exponents. Good.
What exactly is Kw?
All right. That's what we're building up to. We've defined this in terms of just pure water at a specified temperature. Okay? as it turns out, this value holds at 25 degrees Celsius regardless of the relative concentrations of acid and base. In other words, no matter what the concentration of acid is, the concentration of base will then be such that the two of them multiply together to make this number. Okay? So this is true for any acid-base system in water at 25 degrees Celsius. So if you have a system where you have, say, 1 molar hydrochloric acid, which is a strong acid, is there any base there? There's a very, very small amount. Because even if you've got like 1 molar hydrochloric acid, the water is still dissociating to some degree. So you're going to have some base. Now, the amount of base that you're going to have is going to be so small compared to the amount of acid that it's practically negligible. But it's not actually negligible. There is actually some of it there. Usually not enough to worry about. Okay? Thoughts and ideas about that one?
What does KW represent, though?
KW is the auto-dissociation constant for water. In other words, it is concentration H plus, concentration OH minus over concentration of water, but we don't worry about that since it's a liquid. So, we could define KW this way. And in fact, it is defined this way. Okay? That's the definition of KW. We've talked about dissociation constants for different reactions. This is a specific dissociation constant for the reaction of water auto-dissociating into hydroxide and hydrogen ion. And that holds true regardless of what these relative values are. If this one is higher than 10 to the minus 7th, this one by definition has got to be lower. It'll always balance out to give you this value. Laura?
Is that only for 25 degrees Celsius?
Yes, the values change a little bit if the temperature changes.
But it's the same one?
So yeah, there is a constant at other temperatures. The value of the constant changes a little, but it still is a constant, whatever that value is. Okay? Now, understanding this, that the KW represents the relative concentrations of water, of hydrogen and hydroxide, is going to help you in some of your homework problems when it asks you to find, say, the example, concentration of hydroxide in, say, an acetic acid solution. Not going to be much, but there will be some. You'll use this to figure out just how much. All right. Next concept.